Dear students, good morning. Today's topic in Unit 2 is DC generators. So, regarding this DC generators, first we have to know why we are going for the generators. Generally, generators are used to transform energy in one form to that of the other form. Generally, generators are required wherever we need an external electrical energy. So, whenever we face power off on any power limitation conditions, we will be going for the generators since it is going to act as a secondary source of electrical power to any applications. So, what are all the things we are going to see in this topic is, first we are going to see introduction to the generators, next how it is operating, that is principle of operation, and we have DC generator separate. Normal generator is also there, AC generator, and deep of DC generators, and how its construction and working, and finally we are going to see about types and applications. So, this is an introduction to generator, that is it is commonly generators. Normally, electric generator is a device which will convert the mechanical energy into electrical energy. So, this is a simple block diagram showing how the mechanical energy is converted to electrical energy. Normally, a prime mover, which may be a wind or air or anything else which is going to act as a prime mover, and from the prime mover a turbine is moved. So, turbine is going to give a mechanical energy. So, electric generator is going to convert your mechanical energy into electrical energy. Generally, we have two type of electric generators, AC generator and DC generator. AC generator will produce alternating current. DC generator will give you a unidirectional or direct current. Next, we are going to see about what is the essential parts of the generator. The generator must have a uniform magnetic field which may be given by the magnets. Next, a system of conductors, and third, a relative motion between a magnetic field and conductors. These are the essential part for a generator. So, what is the principle behind the working of this generator is Faraday's law of electromagnetic induction. Next, we are going to see about its principle of operation. So, I have said you already it is going to act behind the Faraday's law. So, here I have given you two different laws, first law and the second law of Faraday's. So, first law is nothing but whenever a conductor cuts magnetic flux, an EMF is induced in that conductor. So, whenever a magnetic flux is, we are going to keep two different magnets facing in two different poles. So, a magnetic flux will be generated, and due to that EMF will is induced in that conductor. Next, second law. Second law is nothing but the induced EMF will be equal to rate of change of flux linkage. How the flux linkages are changed, that will be reflected in the induced EMF. This is what the second law of Faraday is. So, you can able to see two different magnets in the diagram, north pole, another is facing south pole. So, whenever opposite magnets are kept, you have a attraction between them. We will call that as the flux lines will travel in between them. If you insert a current carrying conductor inside the magnets, the current carrying conductor will flex the lines. Instead, an EMF will be induced in that conductor, which is going to act as a electrical energy for the working purpose. This is what is shown in this diagram. Normally said DC generator. DC generator is nothing but a generator which produces the unidirectional current. The previous slides we have seen general generators. We didn't gone deep into the DC generator. Normally AC generator and DC generator will have only one difference, that is in the construction. We have slip rings in the AC generator and we have split rings in the DC generators. This split rings is going to give the difference between AC and DC. It is going to act as a converter between AC and DC. This is one form of circuit consisting of DC generator. Another way of converting AC to DC is using bridge rectifier circuit. As we all know, diode is going to act as a rectifier circuit. Diode is a part rectifier which is going to convert AC current to DC current. Either you can have a construction difference with split rings, or we can have a construction difference with the bridge rectifier circuit. So, this is a general construction, that is CS section of the DC generator. When we open the DC generator, we have these parts. The main parts are the frame, that is the first part, which is the outer part, frame or yoke. And next we have the field windings. Inside the field winding we have a pole shoe, and we have a commutator which is going to act as a main converter, and next brush, and then armature, a rotating part, a sealed ball bearing which is going to connect your generator with the other part of the circuit, and we have the shaft at the outer section. These are all the main parts of the generator. We will see one by one later. Yes, the first part of the DC generator is yoke. As I have said, yoke is going to act as the outer part of the generator. It is going to give a protection to the generator. It is going to take care of all the moving parts inside the generator. So, the yoke is formed of iron body. So, it can able to provide utmost strength to the generators. Next is your pole. Pole is nothing but a rectangular cross section which is going to act as a lamination for reducing heat losses. Third is field winding. Field winding is nothing but set of coils which is going to help the steady current flow through the generators. And next, armature. Armature is nothing but it is going to act as a moving part, and it is mounted between poles and the electromagnet. Next, split ring commutator. I have said you already, this split ring commutator is the main part where we are going to convert the AC current into DC current. What is the help of the split ring is, it reverses whenever you can have input in from the AC as positive and negative pulses. So, whenever the direction of the current changes, this commutator will make changes in the external circuit every time whenever the current reverses. So, whatever the current changes, your output will be constant. Your output will be a positive pulse. So, this is how you are converting AC into DC. Finally, brush. Brush is it is connected to the commutator to that of the external circuit for the conduction of the current. Finally, you can able to see a pictorial representation of working of a DC generator. You can able to see two different magnets, north pole and south pole, and you have a conductor in between the north pole and south pole, and you have a commutator, brushes, and you will be connecting a load circuit where you are going to give the output to the load. So, whenever a north pole and south pole are kept, when you induce the magnet, it will produce flux lines in between the north pole and south pole. You will be connecting your conductor in between. You are going to keep your conductor in between north pole and south pole. So, whenever the conductor rotates, whenever the conductor is in horizontal position, you can have your conductor in horizontal and vertical. Whenever it faces a vertical position, you can face the flux lines cuttings. So, instead your current will be generated. The working of the generator is clearly given in the next slide. This is a pictorial representation of your generator. So, this is the theoretical part which I have said you in the working. So, you can able to see this different diagrams started from A to A, that is when what is the position of your conductor. This is what the matters here. When your position is 0, you can able to see the flow waveform here. The waveform will be in 0 position. When it comes to 90-degree position, then your waveform will gets into 90 degree. When it comes to the next rotation, that is 180-degree position, in that case you can face a drop to the 0 position. When again the conductor will be rotating subsequently. So, what is the position of the conductor will indicates you the position of the waveform. Depends upon the position of the waveform, or else the conductor, your waveform will get appear. So, you can able to notice different degrees in the waveform itself. A, B, C, D, A. It is nothing but output of different position of the conductors. Next, we will see about the types of DC generator. You have two different type of DC generators. One is field excitation and permanent magnet. The field excitation is again differentiated into separately excited and self-excited. And again this self-excited is separated into series generator, shunt generator and compound generator. Field excitation is nothing but you have to excite using the external source. The DC generator should be excited using outer source. Permanent magnet is nothing but it doesn't have any excitation, it itself excites. Next, field excitation, we have two different types. One is separately excited and self-excited. We will see each and every one in detail. First, about separately excited. Separately excited is nothing but it has a dedicated DC power supply outside. You need a battery to excite this magnet. But in self-excited, it is excited using its armature itself. The rotating armature itself will excite the field. So, you no need for a DC supply for this. Next, about again you have different type of generator in self-excited. One is shunt, another is series, and third is compound generator. So, next, shunt generator, the field winding is connected in parallel with the armature, whereas in series generator, you have a field excitation, that is, you have a field winding connected in series with the armature. The applications is given as follows. Next, compound generator. The compound generator is nothing but the combination of series and shunt. You will be using it in driving a motor, or you can using it in hotels, office, etc. And finally, this compound generator will have two different things, long shunt and short shunt. The long shunt will be connecting field winding in parallel with the armature winding. But in long shunt, you have shunt field winding parallel with both series and armature winding. So, these are the different type of generators. So, with this generator topic is over. Thank you.